Hello and welcome to another Postgres walkthrough. In this situation, we're going to start talking just about jsonb and Postgres. Everything we've been doing is leading up to this. And so we're going to take a look at my original, from many years ago, export of my, my library in iTunes, and I've converted it into JSON, and so it's got curly braces and double quotes and colons, and I've got one record per line in here. That's the format to do really simple imports for really simple JSON. So I'm going to go in and I'm going to drop this table. If this is not going to exist, but it's not there, so we're fine. I'm going to drop the JTrack table. Then I'm going to create the JTrack table with a ID column and a JSONb body. There we go. We're just like that body is JSONb, and B stands for better, but I like to think of it as binary because it's compressed and it's efficient, and the indexes are like really intricate. It knows a lot. It's not just a big text field. The old JSON was, but JSONb is not just a text field. So the next thing we're going to do is we're going to copy down on a terminal, this JS text file. And that was not found, but here we go. So if I take a look at this library.js text file, you see that it's got this JSON in it, one per line. Now what we're going to do is we're going to pull this in with a /copy command. Now the copy command is only to this PGSQL. And so what we're going to copy into the JTrack table, into the body column from the file library.js text as a CSV. Now it's not CSV, where the quotes are an irrelevant non-printing character, and the delimiter is an irrelevant non-printing character. So EX01 is actually is ASCII number 1, and EX02 is ASCII number 2, and neither of those characters are in, because really the trick is we're only going to pull one column in, and we want the whole line. And we want CSV processing, but then we're breaking CSV processing by telling it the quote is a thing that doesn't exist, and the delimiter is a thing that doesn't exist. So dear CSV, treat each line as just a thing. Don't parse it at all, and because we're only inserting one thing anyways. I wish there was a way to just tell, it's like, it's lines, insert lines. We've done this before in previous things. It's kind of like if Postgres would just let us say, insert this thing as lines, because often that's it. And so we just inserted that. So we can say select count star from JTrack. 318 records. There was 318 lines in there. So there we go. Okay, so let's take a look at what we've got. Let's look at some selections. So we can see, we can pull this out. When it shows us this stuff, it reconstitutes it. So this, in a sense, is not that string that we put in. It's been parsed, it's been stored, and now it's reconstituted. And we can kind of tell that it's a little bit different because we can say, what kind of thing is this? Using the PG type of function. It is, I forgot the semicolon. It's a JSONb, right? It's not really a text string. And that's a string. It just happens to be showing it to us as a text representation of that data structure. We can pull one thing out with this body dash arrow greater than. The key thing to remember is the thing that comes after it's all got to have quotes, because the keys are quotes in JSON. And so we're going to pull that out. Now you can pull out one, we'll see in a sec, you can pull out one or both. This is the one you tend to want to use over and over and over again with two arrows, because that says and convert it to a text field. So that's the kind of select statement. Boom. Now we got that. But we can see if you only have one arrow, we can use type of body dash greater than name, and we'll see what comes back is actually a JSONb. And so JSONb are both documents and fragments of documents. And so this body name is really a tiny little document. And then if we want to, we can convert this to text. But the problem is, if we do it this way, you'll see it's not going to work. If we say body name : text, we get a JSONb. And that's because the association for the parentheses for the : it's a higher precedence operator, and so it happens before the arrow operator happens. And so you got to put parentheses around it. Yeah, you got to put parentheses around it. I don't know. This one doesn't work either because we're going to do the type of. So if we do this parenthesis, it's going to do this and then convert the result of this function. So that means that the function is going to be converted to text. So that's going to break just as bad. It's still the word JSONb. So it just means that you do sometimes have to add extra parentheses so that it actually pulls out the name and then converts and that is a JSONb object. And then we do a cast into text, and that's really what you want. So we get the text, but why are we even doing that? Because if you just do double arrows, it says get it and turn it into text, right? And so that's really nice. I like explaining in gory detail some of these syntaxes because we just throw them out there and we don't know why. And so this is another example. Select max of body count. This is body double arrow count is a string, but then we're going to convert it to integer. Now you got to be careful because the max will work without converting it into an integer, but it'll be a string max, which is like sorting, which means 99 is greater than 1000 because 9 is greater than 1. So you got to convert, when you're doing numeric things, you got to be careful to cast them to integers. Say, there we go. So that actually gets the integer. If you take out the cast of the int, you will see that you'll get 93, which is nowhere near the numeric maximum, but it is that letter 9. That's like a letter, might as well be Z for all we care. And so this means that body arrow count is a string, and so that's the max string from a collating perspective, from a sorting perspective, from an order by perspective. So if we're going to order by something, we're going to this body count cast as an integer. We'll do a select body name as name from JTrack, order by body count, cast as an integer, and then we're going to descend at limit 5 so we can see my most 5 popular pieces of music that I played. And that's because this is some really mellow music that I play in my car all the time, so it gets a really high play count. And so even though count is an integer in JSON, you still need to pull it back that way because it comes back. This first one comes back, body arrow count comes back as a JSON object, and then body arrow count comes back as a text. So you still got to cast it because the double arrow makes it a text. You see that the single arrow makes a JSONb fragment, and then the double arrow makes it a text, and then you have to say : int one more time, and you got to get your parentheses right. So it just is a little bit tricky. Okay, so let's take a look at a where clause. So we're going to count. We're going to count the number of tracks that have a name of Summer Nights, and because it's a body arrow name equals Summer Nights, that says convert it to a text string for me. Which, again, most of the time you just use arrow, and we see that I have one track. We can also say this is a JSONb operator. So that equal operator is a string operator, but the JSONb operator, the at greater than, says, does this body contain this JSON fragment? Now it's going to convert this. There's an implied, it's smart enough to, there's an implied : JSONb on the end of this. Let me actually go just put that in there. It's kind of, this is implied because that is a text string here. Right, so that's implied. Let's even put a parentheses in to make it super explicit for us. So that, but it doesn't need that because it knows that if it sees a string as one of the parameters of the @greater than to convert it to JSONb. So this second version here with the parentheses and : JSONb is really just, it's being explicit of something that's done implicitly, right? So these two things, and we'll see when we start doing indexes that these two things give us the same thing, but this one is a string comparison and one is a JSON comparison with the contains. So then what we're going to do is we're going to show how to use this concatenation operator. We've used this concatenation operator to concatenate strings, but now what we're going to do is use it to concatenate JSONb. And so the body is a JSONb, and we're going to add favorite equals yes. Now this is a string. It's just a string, and inside the string is JSON. It's got to be syntactically correct JSON, quote, favorite, quote, colon, quote, yes, quote. And it's implied, there's an implied conversion to JSONb because it's being concatenated in. And again, the concatenation operator says, oh, if it's a string, I'll convert it to JSONb if the left-hand side is JSONb. And so that's going to work. And so we're going to look up the body. We're going to look at the count variable, convert it to an integer. If there's more than 200, we're going to go ahead and get that. So, so this is basically going to update the body, right? This is going to update the body. Let's do this first and take a look at some of these things. So here we are. So what we're doing is we're going to read and find the count, and then we're going to add at the end a new theme. So that's what this update is going to do. So we take JSONb, it actually pulls it out of the database, sort of reconstitutes it, adds this little thing to it, and then stores it back. And that's what an update does, right? It pulls something out of the database, like update x equals x plus 1. We've done that many times before. So it found 33 rows that the body count is greater than 200, and it added favorite yes. Now if we run this greater than 160, we should see that some of these now have favorite yes. Now again, it's not a string; it's JSONb, but not all of them, right? So this first one here, Winter Wonderland, has a count of less than 200, and so it never got favorite. So now what we have is we have some that had favorite. We could have also written a Python program to tweak this JSON. The fact that this is very simple, but I'm showing you how this concatenation operator works, right? And so we see some with and without the favorite, but then it gives us a wonderful time to play with this question mark operator. So select count from JTrack where body question mark favorite. That's just saying, show me, select the things where the body has the tag favorite, I mean a key of favorite. So that's not saying a key value pair, that's just a key. So how many do I have? That there's 33 that have favorite equals anything. I'm not asking what it's equal to. I'm just saying, is favorite in that JSON? And there's 33 of them. Okay, so let's throw a large amount of CRUD into our JTrack just to make sure the indexes work. So I'm going to put 4,000 lines of unrelated JSONb junk. We're going to select this parenthesis is a big this is a string concatenation. We're going to concatenate, you know, some type colon neon series 24 hours lemons number colon. That's a string. That's just a string. This is a string concatenation, the vertical bar here, and then generate series, if you recall from our previous lectures, creates a vertical replication of rows, generating the number 1000, 1001, 1000, all the way up to 5000. Then I'm concatenating with a closed curly brace. And so that's going to, if you were to just look at this thing right here, right, that would just be a look like JSON. It would be valid JSON. I carefully constructed it to be valid JSON. And then I take that concatenated string and then I cast it as JSONb so that I match the type of body. And so let's go ahead and insert all those. Insert 4,000 more rows. Sometimes you have to insert a bunch of extra rows, or your indexes just, you'll do an explain analyze and you should have used the index, and it's like, well, there's only 12 rows. I might not use the index. And I cannot for the life of me figure out how to convince Postgres to either tell me I would have used the index if there were more rows, or a little thing that says pretend there's a lot of rows in it, because I'm really trying to debug my index. So but you see when you look online at blog posts and stuff, you see that they just put a lot of rows in there, and so you just got to figure out how to generate series and put some more rows in. So we're going to make some indexes. These indexes aren't there because I just built it, but we'll drop them anyways. let's go ahead and create 3 indexes. I'll create them. I'll fire them off, create them all, and then we will see. Sometimes you got to wait, so I'm gonna explain. we'll let Postgres in this tab grind away and make sure those indexes are ready so our explain start working. So I'm going to use 3 indexes. One is a B-tree index, and in that my expression is to pull out and convert to a string the name key. Right, so pull out the name, not the fact that the name exists, but the fact that, you know, name equals the name of the track. So like Summer Nights. So this B tree is going to hit that where clause, where body name equals Summer Nights. So that's a B tree index. And so this is more of a traditional old style index, but you gotta, B trees want to index, in a sense, a field. One string is what they want, or a combination of strings. You can put more than one in there. And so the key is that this B tree will hit body name equals Summer Nights, but in a query like body artist equals queen, that will not hit it because we did not make an index on body artist. We could make another index on body artist if we want, and then this would work. Now the key is the operators of the where clause are critical, and so the question mark and the @ sign are the gin, deal with the gin indexes. The equal sign is a string comparison. It's really not, in this respect, it's not at all a JSONB operator. It's the data is stored in JSONB, but where clause is reading the JSONB, pulling out the artist or name, and then doing the string comparison. And so that's why it hits the B tree. There's just no way that these last 4 would hit the B tree, and there's no way that the first 4 would hit the gin, because equal is not a gin operator. Okay, so that's the B tree. So you can, and this is, I should stop here and talk about like how gorgeously beautiful this is. You can you can have a JSONB and you can dive in and you can make a beautiful B tree index, which makes, you can put a logical key deep inside of JSON if that's what you want. And it, for all intents and purposes, is going to be super fast as even if you pulled that name out and made another column, as you've seen me do in a couple other places. So that's like awesome. Okay, so that's easy and awesome. You got to know how to construct your where clauses to make use of that particular thing, but that's like any other query. Okay, so let's take a look at the gin one. So create index jtrack gin on jtrack using gin body. Now we're going to do a gin of the whole body. Now the default is that what this is going to click is this is going to figure out whether or not this is going to remember the keys, not the key value pairs. Okay, and so it'll click this body question mark favorite, which is like, is that key there? And then, but then to get the things like name Summer Nights or artist Queen or name Folsom Prison Blues and artist equals Johnny Cash, which is what we're doing in these last 3, we're going to make another index that's asking for the path ops. And so the difference between a gin on the body and a gin with JSONB path objects on the path ops on the body is that it looks at key value pairs and is super fast. Now, of course, the JSONB path ops is bigger and slower and harder to maintain, but it does hit on more of the where clauses. So these last, the gin and the gin path ops hit these the question mark operator and the does body JSON contain this little bit of JSON, right? So let's just take a look at hopefully which of these things hit and which of these things don't. Now you might think it'd be nice if because we've got a gin with the JSON path ops, that it would figure out, oh, name equals Summer Nights, and in effect convert that to this body at greater than name colon Summer Nights, but it doesn't. But it could. Some future version of Postgres might decide to make the equal sign operator smarter when it's dealing with JSONB, but who knows? We can't expect that. So let's take a look at these one at a time. See if our indexes are done. No. Oh, yeah. Okay. I freaked out because I saw sequential scan. That's what you're supposed to do whenever you do an explain analyze. But this is body artist. I did not make, I made it on body name. And so that's supposed to be sequential. Now, if we name Summer Nights, this is going to use the B-tree index. And there you go. It hit the B-tree index because that is the thing that I made the B-tree index on, is body arrow arrow name. And so it hit just fine. And again, I think of this as just as efficient as if I had made a column, right? So if we ask, look for the ones where the word favorite, where there's a favorite key, not any particular key value pair, that's going to successfully hit the JTrack gin, because the gin says what keys are what. And so that, I don't know, I tend to feel like if I was doing this, I can't figure out how often I'm going to want this, unless I have some really diverse documents that have widely differing syntax, and I've got some kind of a thing where I just have an indicator that says, you know, blah 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 equals blah blah blah, you know, and I'm just like, it's a marker, which is kind of what this favorite yes is. It's kind of like a marker. So just the presence of it. Again, the gin is faster and smaller than the gin with path ops. Now we're going to have some fun. So now we're going to say, go find me the name Summer Nights, and we're going to be using the gin path ops. All right. So we're doing name. So does this body contain this little JSONb fragment name Summer Nights? And the answer is we'll find it, and this is going to find it, and that means that there's an index that's smart enough to look at nothing but this and pick the rows and then only retrieve those rows. Now, because we did it, it doesn't really care which of the keys we're looking at. We can say Artist Queen, because it's got that one too, right? So it did all of them. Unlike the B-tree where we picked which one it did, the gin path ops just picks them all, just all the combinations. And then we can say, and read this one carefully, select count star from JTrack where body contains name Folsom Prison Blues, artist Johnny Cash. This is like an and, because we're saying, is this entire subset of JSON, name Folsom Prison Blues, artist Johnny Cash, is that contained within the body JSON? Got it? So that's like an and operation. Okay. And that one hits the JSON path ops, and it works just fine. So that is sort of really beautiful, really impressive. Like most things in JSON and Postgres, once you get down to doing the work, you know what to do. It works out pretty cool. And so this this last little bit, we're going to do an update. This is just kind of an advanced thing. So let's say we're going to we want to add 1 to a count, right? So we want to take this count somewhere here, count 55, and we want to add 1 to that. It is an integer, and it knows it's an integer, but we got to get stuff a little tricky, and this kind of gets you to the point where you have to construct this stuff, and it takes a while to figure out. And that's why when I figure this out, I write it down. So here, let's start by saying select body count JTrack +1, because we would like to be able to do that because it's an integer, right? And, hey, give me this thing as an integer. That'd be my instinct. I'd like to be able to use that syntax. And the answer is, sorry, you have given me a JSONb and an integer, and I'm not going to allow you to add those things together. So that's where you got to cast it. So cast the body count, cast : int. Now we can actually calculate the updated. So now it was 55 and now it's 56. Let's just select it so you can see what it is without the +1. So it was 55, and so now if we add 1 to it, cast it to an integer and add 1 to it, we're going to get 56. So we can, do a select here and add 1 to it for the Summer Nights, and we're going to add 1. So we can also take the +1 away, and we see what the old one was. So we can put a where clause on here, and that's really just putting a where clause, so 35 going up to 36. Now, this is the mess. This part here is the mess. Update JTrack set body equals JSONb set. So what this is doing is it's actually, I would love for this to be some kind of concatenation or something a little prettier, but they put this into a function. And so what it does is it takes the old JSONb and it takes a path, which means go find the count thing. That's a really weird syntax, but it's the right syntax. And then take the body count, convert it to an integer, add 1 to it, then convert it to text, and then convert it to JSONb. I don't like this syntax. I think there's a more elegant way to do it, and perhaps in a future version of Postgres they will make this more elegant, and then I can throw a where clause on this. So update jtrack set body equals, so this is retrieving the entire body, tweaking it with this function, and then storing it. Now the hard part is really retrieving and then storing this new data. So it's not all that bad. It's just I don't like the syntax of it. It's a little bit hard. I have it here in case you want to do it in the future. For me, I would be like, no, I think I'll just make count. I'll just pull count into its own column and then mess with it there. Okay? So now that we're all done with this, I'm just going to clean things up. I like to drop my tables, and so I'll drop table jtrack cascade because I'm using a Postgres server that has a limited amount of memory. So I hope that this sort of walkthrough of the general use of JSONb has been useful to you, how the operators work, how the casting works, etc.